Yucca the woolly. Mammoth. The ground thaws, a tusk breaks the surface, and standing in the mud of a Siberian riverbank is something that should not exist. A creature dead for 39,000 years, its fur still the color of rust, its blood still liquid in its veins. Not fossilized, not a skeleton, a body. In 2010, hunters along the Laptov Sea coastline in northeastern Siberia spotted a carcass eroding out of the permafrost. They named her Yucca after the region. By the time researchers from the Northeastern Federal University in Yakutsk arrived, what they found in that frozen riverbank defied every expectation of what a nearly 40,000-year-old specimen could be. Lead scientist Semyon Grigoriev described pulling back the ice and watching dark red liquid pool in the cavity beneath her body. Liquid blood, in an animal dead since the last ice age. The numbers alone are staggering. Radiocarbon dating confirmed her death at approximately 39,000 years ago, placing her well within the Pleistocene, an era most of us imagine only as bones in a glass case. Her coat, reddish-brown, with a dense winter undercoat, was intact enough to resolve decades of debate about how mammoths actually looked. Her brain, partially preserved, was the first mammoth brain tissue ever extracted by science. An analysis published in the Journal of Paleontology described cellular structure still present within it. She was a juvenile, estimated at between 6 and 9 years of age based on molar wear, which partly explains the completeness of her preservation. But only partly. What made Yucca internationally significant was not just her coat or her brain. It was the blood. Mammoth hemoglobin had already been shown by geneticist Kevin Campbell and his team to function at sub-zero temperatures, which explains why the blood did not fully crystallize inside her tissue pockets. But knowing why the blood could remain liquid and explaining how it survived 39,000 years beneath the permafrost without degrading into nothing are two very different problems. Her muscle tissue, described by Grigoriev's team as appearing fresh in color and retaining structural integrity, pushed those questions further. Japanese researchers from Kinki University arrived to sample her cells as part of the Mammoth Revival Project, an effort eventually connected to Harvard geneticist George Church's work on Pleistocene de-extinction. The goal was simple and extraordinary: find a viable cell nucleus. Yucca was the best candidate anyone had ever found. And then there were the wounds, claw marks on her hindquarters, consistent with cave lion predation, and possible butchery marks suggesting that ancient humans encountered her carcass. Someone stood over this body 39,000 years ago. They looked at what we are still studying today. What they made of her, we will never know. The scientific explanation for her preservation is straightforward enough. Rapid burial in cold, waterlogged sediment followed by stable encasement in permafrost halted decomposition before it could progress. The permafrost beneath the Siberian active layer is extraordinarily stable, and once a carcass is sealed below it, bacterial activity essentially stops. The anti-freeze properties of her hemoglobin account for the liquid blood. Each piece of the explanation is defensible. But the explanation tells us how each individual mechanism functions. It does not account for why this level of preservation, liquid blood, intact neurons, fresh-looking muscle fiber in a large-bodied juvenile keeps appearing in the same region across tens of thousands of years. Yucca is not an isolated case. She is one entry in a growing catalog. And that catalog is expanding as the permafrost thaws. Some researchers have quietly asked whether northeastern Siberia functions less like a random preservation environment and more like a structured archive, a zone of specific geological conditions that captures organic material with a precision we have not yet fully mapped. If so, the question is no longer why Yucca survived. The question is, how many more are in there, and what they are still holding on to? From the frozen riverbanks of Siberia, we cross the top of the world to the black, airless quiet of a Danish peat bog, where the preservation was just as perfect and the mystery is far darker. The Tolland Man. It is the 8th of May, 1950. Two brothers cutting peat in a bog near Tolland in central Denmark push their spades into the earth and expose a face. Not a skull. A face. Closed eyes, faint stubble on the jaw. An expression so calm it stops them completely. They put down their tools and call the police, certain they have found a recent murder victim. The detective who arrives takes one look and agrees. The pathologist who examines the body will later say it is the best preserved human face he has ever seen. The man has been dead for 2,300 years. The Tolland Man is now housed at the Silkeborg Museum in Denmark, where he has been studied for more than 7 decades by researchers ranging from botanists to forensic pathologists to CT radiologists. What those studies have built up, layer by layer, is a portrait of a death so specific and so strange that it resists every simple explanation. The National Museum of Denmark's radiocarbon analysis places his death between 375 and 210 BCE, with the most probable window around 300 BCE. He was hanged with a braided leather cord, a finely crafted slipknot noose still around his neck at discovery. Forensic examination confirmed death by hanging rather than strangulation. The hyoid bone was intact, consistent with a drop that broke the neck rather than a slow garroting. Someone who knew what they were doing made that knot. His stomach contents, analyzed by botanist Hans Hellbeck in 1950, identified a meal of barley, linseed, pale persicaria, and at least 30 additional plant species eaten 12 to 24 hours before death. The composition of the meal matched late winter or early spring vegetation, fixing the season. His fingernails were manicured. His hands showed no signs of heavy labor. CT scanning conducted by Aarhus University Hospital in 2015 revealed that his brain, though shrunken, had retained its surface structure, including the convolutions visible on the outer cortex. The bog had tanned his skin like leather, drawn out moisture, and locked him in time. The chemistry behind this is well understood. Ambrotrophic raised bogs, the deep peat formations of northern Europe, create near-perfect anaerobic conditions. The sphagnum moss produces a natural tanning agent. Cold temperatures, low oxygen, and high acidity combine to halt bacterial decomposition with extraordinary efficiency. It is not magic. It is a very specific set of chemical circumstances that happens to produce results indistinguishable from what most people would call a miracle. But the chemistry explains how he was preserved, not why he was placed there. He was not thrown in. He was carried in and arranged. Eyes lightly closed, body curled into a sleeping posture, legs drawn up as if someone set him down gently after killing him. Across northern Europe, researchers have recovered more than 1,000 bog bodies, and a significant number of them show the same pattern: deliberate positioning, signs of ritual killing, objects left with the body. Peter Glaub of Aarhus University spent decades studying these finds and proposed in his 1965 book on the bog people that they represented sacrificial victims offered to the goddess Nerthus during Iron Age fertility rites. He called the pattern of multiple simultaneous cause-of-death wounds the threefold death, and it appears on geographically separated bodies across cultures that had no documented unified religious authority. The mainstream view is that the Tolland Man was a ritual sacrifice, executed and deposited in the bog as an offering, his unusual preservation a fortunate accident of chemistry. That explanation is credible. It fits the evidence. But it doesn't explain who chose him or why his hands were soft. It doesn't explain who stood over the body after the killing and took the time to close his eyes. And it doesn't explain why 1,000 people across 1,000 years of Northern European history were sent into bogs using rituals so similar they read less like regional folk practice and more like a shared protocol. A protocol written by someone for a purpose we have not decoded. From the black water of a Danish peat bog, we travel east, thousands of miles east, deep into the desert heart of western China, where the dead are also perfectly preserved, and they have no business being there at all. The Tarim Basin. Mummies, you are standing in western China 2,000 miles from the nearest ocean, surrounded by one of the most inhospitable deserts on Earth. You are looking at the face of a woman who died 4,000 years ago. Her hair is auburn. Her nose is sharp and narrow. She is nearly 6 feet tall. Everything about her face tells you she belongs somewhere in Europe. Everything about her location tells you that is impossible. The Tarim Basin mummies have been coming out of the Taklamakan Desert since the early 20th century, but it was University of Pennsylvania linguist and archaeologist Victor Mayer who, beginning in 1988, first conducted systematic analysis of what these bodies represented. What he found forced a complete reassessment of Bronze Age Central Asia, and the reassessment is still not finished. The Taklamakan Desert is one of the driest places on Earth. Temperatures swing from extreme heat to intense cold, and the soil is laced with salt. Those conditions draw all moisture from buried tissue before decomposition can establish itself, creating natural mummies of extraordinary fidelity. The most famous specimen, known as the Beauty of Lulan, dates to approximately 3,800 years ago. Her hair, her woven clothing, and the fine structure of her face are preserved with enough detail that forensic specialists were able to create a life-size reconstruction now displayed at the Urumqi Museum in Xinjiang. Textile analysis by Irene Good of the Peabody Museum at Harvard identified the mummy's woven wool clothing as using a twill weave technique found in Bronze Age Central Europe, specifically resembling patterns associated with the Hallstatt culture. The tallest male specimen, known as Churchin Man, stands approximately 6 feet 6 inches. He was found buried alongside 4 women and an infant, the baby swaddled with small blue stones placed over its eyes. Their burial goods included cattle bones, wheat grains, and dairy products. A specifically Western Eurasian subsistence package appearing in the middle of a desert with no known archaeological predecessor culture in the region. Victor Mayer's linguistic analysis confirmed that the Tarim mummies spoke an early form of Tocharian, an Indo-European language representing the easternmost known branch of that language family, previously believed to have arrived in the region far later than the mummy's date range suggests. Then, in October 2021, a landmark genetic study published in the journal Nature, led by researchers including Chungwon Zhang and Vaghish Narasimhan, delivered a result that silenced the debate about migration and replaced it with a deeper puzzle. The genomes of 13 Tarim Basin individuals dating to approximately 2100 to 1700 BCE showed no detectable ancestry from any surrounding Bronze Age population. Not steppe nomads, not East Asians, not South Asians. They appeared to descend from an ancient North Eurasian lineage that had been genetically isolated for thousands of years. Geneticist David Reich described this as one of the most striking cases of genetic isolation in the ancient world. The mainstream interpretation following the 2021 study is clear. These were not migrants who traveled to the basin. They were an isolated indigenous population, a remnant of an ancient lineage sealed off by geography for millennia. Their Western physical features reflect deep shared ancestry, not recent contact. The desert did the rest. But the genetics resolves one question and opens a harder one. If they arrived from nowhere detectable in the archaeological record, if there is no traceable migration route and no genetic connection to contemporary neighbors, then what exactly was this population? Where did it come from, and why does it leave no descendants in the modern genetic landscape? Ancient North Eurasian populations are known from the Pleistocene. Finding an intact isolated remnant of one fully functional, farming wheat, herding cattle, weaving European-style textiles in the center of a Chinese desert 4,000 years ago is not a tidy conclusion. It is a question wearing the clothes of an answer. Some researchers have suggested the Tarim Basin may have served as a refuge, a place where a remnant of something older survived while the world around it changed. If so, the blue stones over the infant's eyes, matching no known burial tradition in the surrounding region, may be the last visible trace of a theology that had nowhere else left to go. From the desert-dried faces of people who shouldn't exist in China, we climb into the ice of the European Alps, where another impossible preserved body was waiting, and where the mystery isn't just about how he survived so long, it's about the last hour of his life. Otzi the Iceman. The 19th of September, 1991. Two German hikers cresting a mountain pass in the Alps spot what they take for a discarded doll sticking out of the ice. Then they see the skin, then the hand. Someone is lying face down in the glacier, fully clothed, arms at his sides, as if he sat down for a rest and never got up. The rescue team that arrives assumes a recent accident. The pathologist who examines him will determine he has been lying in that pass for 5,300 years. Otzi was found on the border of Austria and Italy at an elevation of 3,210 meters, in a sheltered hollow just below the main glacial ice flow. That specific geography saved him. Most bodies caught in glaciers are ground to fragments by the slow mechanical pressure of moving ice. Otzi's hollow kept him below the grind zone, frozen and still, while the world above him transformed beyond recognition. He now rests in a purpose-built cold chamber at the South Tyrol Museum of Archaeology in Bolzano, maintained at -6 degrees Celsius and 99% humidity, and what he has told researchers over 30 years of study is extraordinary. Multiple laboratories, including the University of Oxford, confirmed his age through radiocarbon dating. A 2001 X-ray, followed by a 2007 CT scan conducted by Paul Gostner and Eduard Egarter Wiegel at the Regional Hospital of Bolzano, found an arrowhead tip lodged in his left shoulder, its shaft removed, the subclavian artery severed. He bled out in minutes. He was shot from behind at a distance of roughly 30 meters by someone he did not see coming. His last meal, identified through stomach content analysis published in 2018 in the journal Current Biology by Frank Meixner of URAC Research, showed approximately 50% of his calories came from wild ibex fat, alongside red deer meat, einkorn wheat, and bracken fern. It was a carefully assembled high-calorie meal for high-altitude travel, eaten 30 to 60 minutes before his death. His equipment was in good repair. He showed no signs of flight or defensive wounds. He had no idea he was being followed. He carried 61 tattoos, confirmed as the oldest tattoos ever found on a human body. Researcher Lars Krutak and others noted that the tattoo locations correspond almost precisely to arthritic degeneration sites found in Otzi's skeleton, leading to serious scholarly proposals that they represented a therapeutic intervention, a form of pressure point treatment predating any known acupuncture tradition by centuries. His copper axe, nearly pure in composition at 99.7% copper, was traced through DNA analysis to ore deposits in southern Tuscany, more than 500 kilometers from where he died. Someone moved that metal across the Alps in 3,300 BCE. Pollen analysis by Klaus Ugel of the University of Innsbruck reconstructed Ötzi's final 2 days of movement. A low-altitude valley roughly 33 hours before death, then a rapid climb to altitude. And then in 2023, a revised genetic analysis overturned every physical reconstruction that had been made of him. Ötzi had dark skin, dark eyes, and male-pattern baldness. Every museum model, every documentary depiction, every textbook image was wrong. The man we thought we knew looked nothing like the man who actually died in that pass. The mainstream explanation for all of this is coherent. A Copper Age man of high status, possibly a community leader, was assassinated in an interpersonal or political conflict. His preservation was a geological accident. The copper axe, the tattoos, the precise diet are evidence of a sophisticated alpine culture archaeology is still reconstructing. But consider what the arrowhead tells us. It was identified only in 2001, a decade after discovery, because it was missed in every previous examination. The attacker removed the shaft. Ötzi's stomach was full. His gear was intact. He was not running. Someone chose him specifically, followed him to an elevation of 3,000 meters, and then removed the evidence. His copper axe, the most valuable thing he carried, was left behind. Robbery was not the motive. What knowledge, what authority, what secret died in that glacier with him is a question the ice has preserved perfectly and answered not at all. From the ice of the Alps, we descend into the heat of an Egyptian tomb, where another impossible body was preserved, and where the mystery isn't just about how he survived. It's about what someone needed the world to remember about the way he died. The Screaming Mummy. In 1881, archaeologists working the greatest mummy cache ever discovered in Egypt opened a plain white coffin and recoiled. Inside was a face locked in agony. Mouth wrenched open, head thrown back, hands bound at the wrists. Every other mummy in the cache had been honored, named, wrapped in royal linen, and placed in a cartouche-inscribed coffin. This one was bundled in sheepskin. In ancient Egypt, that is not an accident. It is a deliberate desecration. And for 150 years, no one could agree on who he was or what he had done. The cache at Deir el-Bahri, designated DB 320, was sealed in antiquity by priests of the 21st dynasty who were trying to protect the royal dead from tomb robbers. When Egyptologist Emil Brugsch opened it in 1881, he found 40 royal mummies inside, including Ramesses II and Seti I. Unknown Man E was the anomaly in every possible way. No identification, no standard wrapping, sheepskin, bound wrists, and a face that looked nothing like sleep. CT scanning conducted by Sahar Salim of Cairo University in 2012 revealed that no embalming incision had been made, a deliberate omission from standard royal mummification. His organs were still present inside the body cavity, partially desiccated but intact, including structures that normally would have been removed and placed in canopic jars. The binding cord impressions were visible in the skin of his wrists, indicating the hands were tied at or immediately before death, not as a post-mortem ritual gesture. Forensic analysis of the posture, open mouth, retracted head, rigidly extended neck, is consistent with cadaveric spasm, a rare phenomenon in which the body freezes in its final muscular state at the precise moment of violent death. This man, by the physical evidence, died in terror. The sheepskin wrapping is unique in the entire Egyptian archaeological record. Sheep were considered ritually impure in ancient Egyptian religion, making this choice a theological statement. Someone mummified him using enough skill and resources to produce a body that is still intact 3,000 years later, then wrapped that body in the one material guaranteed to communicate shame, sealed it in an unmarked coffin, and hid it among kings. The leading identification, proposed by Egyptologist Zahi Hawass and supported by DNA analysis, published in the British Medical Journal in December 2012, is Prince Pentauer, son of Rameses III. A historical document known as the Judicial Papyrus of Turin, dated to approximately 1155 BCE, records that a harem conspiracy to assassinate Rameses III was uncovered, and that the prince involved was condemned and left, in the papyrus's own language, with his worthless body. The DNA analysis by Hawass and Salim found a Y chromosome match consistent with a paternal relationship to Rameses III's confirmed mummy, supporting the identification. The textual record, the genetic data, and the physical evidence point in the same direction. But the Pentauer identification, convincing as it is, deepens rather than resolves the strangeness. The judicial papyrus says he was left with his worthless body, a phrase scholars interpret as denial of proper burial. Yet someone mummified him well enough to preserve his face for 3 millennia. Someone put him inside a cache built to protect the holiest of the royal dead, surrounded by pharaohs, sealed by priests sworn to guard them. If the intention was disgrace, why not a pit? Why not destruction? Why this particular form of preservation in this particular company? Some researchers have asked whether unknown man E served a purpose beyond punishment. In several ancient traditions, the preserved image of suffering carried protective or apotropaic power. Whether the screaming face was meant to be seen by the priests who sealed that chamber, whether it functioned as a ward or a warning or something else entirely, is a question the mummy cannot answer. What it can tell us with absolute clarity is that someone stood over this body after the killing, wrapped it with intention, and placed it where it would be found. Not lost, found. By someone, eventually, by us. From the desert heat of an Egyptian tomb, we travel north and east into the frozen mountains of the Altai, where a woman was buried with 6 horses, a headdress a meter tall, and arms covered in a mythology that her own government tried to keep secret for 20 years. The Princess of Ukok. The year is 1993. Russian archaeologist Natalia Polosmak is excavating a burial mound on the Ukok Plateau in the Altai Republic of southern Siberia, at an elevation of roughly 2,300 meters. Getting there requires days by horseback. The plateau sits at the junction of Russia, China, Kazakhstan, and Mongolia, a place so remote that the sky feels closer than the nearest town. When Polosmak's team reaches a particular kurgan, a burial mound of the Pazyryk culture, and begins to excavate, they find a larch-wood coffin sealed with copper staples and packed in ice. Inside, preserved for 2,500 years, is a young woman. Around her, 6 horses in full bridle and saddle are arranged in a single ceremonial line, sacrificed and positioned with the care of a final performance. Her arms, from shoulder to fingertip, are covered in tattoos. The Pazyryk culture occupied the Altai Mountains from roughly 600 to 200 BCE, and archaeologist Sergei Rudenko's excavations in the 1940s and 50s had established them as sophisticated nomadic pastoralists with extraordinary artistic traditions. But nothing from those earlier digs prepared researchers for what the Princess of Ukok's arms contained. Using multispectral and ultraviolet imaging, a documentation project affiliated with Iraq Research produced a full visual reconstruction of the tattoo designs, and what those images revealed was not a tribal marking system. It was a narrative. Mythological deer with antlers that transform into griffins. A snow leopard caught mid-leap. Creatures flowing into each other as the arm turns, each figure continuous with the next, the entire sequence designed to be read in motion. Polosmak stated in a 2012 interview that the complexity and coverage of the tattoo work suggested the woman was not simply a noblewoman, but likely a keeper of sacred knowledge, a figure whose body was itself a kind of living text. Radiocarbon dating confirmed her death between 500 and 400 BCE. She was estimated at 25 to 28 years of age at the time of death based on bone density and tooth wear. The 6 horses sacrificed alongside her were equipped with bridles decorated with carved wooden griffins covered in gold leaf, an investment of labor and material that speaks to a status beyond simple aristocracy. Her headdress, reconstructed from fragments found in the coffin, stood approximately 1 meter tall and was similarly decorated with carved wooden birds sheathed in gold. Forensic analysis conducted prior to repatriation revealed evidence of breast cancer and osteomyelitis, a bone marrow inflammation that would have caused severe chronic pain throughout much of her adult life. Alongside the coffin, researchers found a container holding cannabis seeds. Some researchers have proposed she used psychoactive substances ritually, perhaps as part of her role or as a means of managing pain, though this interpretation remains contested. Perhaps the most quietly astonishing detail of her burial was the textile found among her grave goods, a white silk blouse. Silk, in the Altai Mountains in approximately 400 BCE, implies a trade network extending to China across a distance and through terrain that should have made regular contact nearly impossible at that period. The blouse exists. The trade route, by implication, also existed. What else moved along it, and what knowledge traveled with the silk, is a question the plateau does not answer. The mainstream classification is clear. A high-status Pazyryk woman, possibly a ritual specialist or spiritual practitioner, buried according to the elaborate funerary tradition documented across multiple Kurgan excavations. The permafrost preservation is well understood. The tattoos are consistent with Scythian animal-style art documented across the Eurasian steppe. But the Altai Republic government and local indigenous communities did not react to her discovery as an archaeological find. They reacted as if a living sacred figure had been disturbed. A formal repatriation dispute lasted nearly 20 years before she was returned in 2012. Some researchers have asked how an oral tradition preserved the recognition of a specific woman buried on a remote plateau for 2.5 millennia, and what exactly that tradition remembered about her. The tattoos on her arms may be the most detailed answer she left behind. We are only now beginning to read it. From a woman whose body was a sacred text, we descend from the mountains into a mine where the earth itself became a preserving jar and kept reaching up decade after decade to pull workers into its permanent dark. The saltmen of Iran. A salt mine does not let go easily. In 1993, miners at the Chehrabad mine in the Zanjan province of northwestern Iran were cutting through a salt seam when they hit something that was not rock. It was a foot, a human foot still inside a leather boot attached to a leg, attached to a man preserved in salt for 1,700 years. They called him Saltman 1. They had no idea the mine was about to give them 5 more. Systematic excavation by the Iranian Cultural Heritage Organization, conducted in partnership with international teams including researchers from Stony Brook University and the German Archaeological Institute, recovered Saltman 2 through 6 between 2004 and 2010. What the dates revealed was perhaps more unsettling than any single find. These men did not all die in the same accident. Their radiocarbon dates span a range from approximately 300 BCE to 400 CE, meaning the mine was claiming workers across 6 centuries of continuous operation. 3 different empires, the Achaemenid, the Parthian, and the Sassanid, came and went above this mine. The mine kept working. The mine kept killing. Saltman 1's preservation is the most complete of the group. He retains a full head of long, reddish-white hair, a groomed beard, intact leather footwear with the stitching patterns still legible, and iron knives still housed in their belt pouches. walnut fragments found near the body may represent his last meal. His hair shaft structure was preserved well enough that researchers at the University of Vienna were able to identify keratin protein sequences from it, making it among the oldest recoverable protein data from human hair in the region. Saltman 6, dated to a later period, retained fingerprints clear enough for forensic classification using modern ridge pattern systems. Whorls, loops, and bifurcations still readable to the naked eye after 17 centuries underground. A brain recovered from one of the Saltmen, analyzed by researchers affiliated with Stony Brook University, was described as shrunken but structurally coherent, with neuronal structures and lipid chemistry consistent with preserved but chemically altered tissue. Biomolecular analysis of associated food remains and textile fibers was conducted by teams linked to the German Archaeological Institute's Tehran branch and published in the Journal of Archaeological Science. The chemistry of salt preservation is well understood. Halophilic bacteria, the microorganisms that would normally decompose a body, cannot survive in environments where salt concentrations exceed approximately 15%. The Chehrabad deposit dramatically exceeds that threshold. Salt also draws moisture from tissue with extraordinary efficiency, replacing cellular fluid with mineral crystalline structures that lock the physical form in place. The result is not simply preserved skin. It is mineralized tissue, hardened from within, capable of surviving for centuries in conditions that would reduce an unprotected body to nothing within weeks. The deaths appear to have been caused by mine collapse. Body positions and associated rock debris are consistent with sudden overhead falls, and the fact that none of the saltmen were recovered by contemporary miners suggests the collapses that killed them were catastrophic enough to permanently seal those sections of the tunnel. The ancient miners could not get back in, neither could anyone else, for centuries. But here is what the chemistry cannot answer. This mine was known to be dangerous. It had killed people. And yet it kept operating for 600 years, through the rise and fall of 3 empires, through wars and conquests and complete political reorganization. What was worth that? Salt was not simply a food preservative in the ancient world. It was currency, it was tribute, it was the foundation of economies and the subject of military campaigns. The Latin word for salary derives from salt payment. This mine was worth dying for, apparently, over and over again across 6 centuries. Some researchers studying the Chehrabad saltmen have quietly raised a question that the chemistry alone cannot dismiss. Is it possible that the ancient miners knew, on some level, that the salt preserved the dead? That the strange, intact quality of the bodies in the collapsed tunnels was understood as a sign of something, whether divine favor, special power in the mineral, or something else the texts do not record? If they knew the salt kept the dead whole, what did they make of that knowledge? And does it change what it meant to a Sassanid worker descending into those tunnels in 300 CE to know that everyone the mine had taken was still down there, waiting exactly as they had fallen? From a mine that kept its dead for centuries in Iran, we fly northeast back into the Siberian cold, where a creature so rare only one had ever been found before was pulled from a riverbank by a child, so perfectly preserved that scientists initially questioned whether she had died last year. Baby woolly rhinoceros Sasha. In August 2014, a teenager was walking along the eroding bank of the Semyulyak River in the Sakha Republic of northeastern Siberia when a chunk of permafrost collapsed and exposed a horn. Then a face, then 4 legs. An entire rhinoceros, the size of a large dog, so completely preserved that the nostrils still held shape, the ear still had cartilage, and the coat was still attached to the skin. She had been dead for 34,000 years. She looked like she had been dead for a week. Sasha, as she came to be known, was transferred to the Academy of Sciences of the Sakha Republic in Yakutsk and the scientific results that emerged from her study over the following years were remarkable for reasons that went beyond her obvious visual completeness. Detailed analysis published in 2020 by a team led by Valeria Plotnikov of the Yakutian Academy of Sciences, with genetic work conducted by the Center for Paleogenetics in Stockholm, revealed that Sasha was not simply a well-preserved juvenile woolly rhinoceros. She belonged to a previously unknown genetic lineage. The basic facts first. A radiocarbon dating placed her death at approximately 34,000 years before present, well within the last glacial maximum and contemporary with the last Neanderthal populations in Europe. Her age at death was estimated at 3 to 4 years, based on tooth eruption patterns, old enough to be independent from her mother, but still firmly within the juvenile developmental range for the species. Her nasal horn, intact and still attached to the nasal bone, measured approximately 18 centimeters. That detail alone resolved a long-standing debate. Scientists had disagreed about whether woolly rhinoceros calves developed their distinctive horn early or late in life. Sasha settled it. They grew it early. Her coat color, recorded directly from the physical specimen rather than inferred from cave paintings, was a warm brown-gray with a denser, darker undercoat, the most accurate color data the species had ever yielded. Isotope analysis of her tooth enamel indicated she had been consuming terrestrial plant material consistent with late summer or early autumn vegetation, narrowing her season of death and confirming she was in good nutritional health immediately before she died. Researchers found no predator wounds, no signs of drowning, no evidence of starvation. She simply died, fell into permafrost, and stayed there for 340 centuries. The genetic analysis published by Adana Lord and colleagues at the Center for Paleogenetics identified Sasha as belonging to a mitochondrial haplogroup not previously detected in woolly rhinoceros remains. This was not a minor taxonomic footnote. It meant there was an entire genetic lineage of woolly rhinoceroses, potentially a distinct subspecies, that had been completely invisible to science until a child in Yakutia stumbled across a collapsing riverbank. The lineage had vanished without leaving a trace in any specimen previously recovered, bone or otherwise. Only frozen soft tissue could have carried the genetic data to identify it. The mainstream explanation for Sasha's preservation is the same as for any Siberian permafrost find: rapid burial in frozen sediment following death, encasement below the active layer, stable cold halting decomposition indefinitely. This is scientifically sound. Sasha is not the first woolly rhinoceros calf found with soft tissue, only the most complete. The first, a specimen named Borya, recovered in 2007 from the same region, was fragmentary by comparison. But Sasha is not simply a data point. She is one entry in a catalog of Siberian Pleistocene soft tissue finds that includes cave lion cubs, cave bear cubs, Pleistocene wolf heads, and multiple mammoth specimens, all from the same general drainage basin in northeastern Yakutia. Standard permafrost models explain each find individually. None of them fully account for the concentration. Some researchers have begun to ask whether this specific zone of northeastern Siberia functions as something more purposeful than a random cold archive, whether particular geomorphological features create preservation corridors that capture organic material with a precision we haven't fully mapped. And then there is the simpler, stranger question. Sasha was healthy. She was well fed. It was late summer. She was 4 years old. She died with no apparent cause, fell into the permafrost, and waited 34,000 years for a teenager to walk past. Whatever killed her left no mark. The permafrost kept the secret perfectly. From the silent death of a young rhinoceros on a Siberian riverbank, we go deeper into the permafrost archive to an animal whose death was anything but silent and whose last meal may be the single most important piece of evidence in one of the oldest unsolved arguments in paleontology. The Berezovka mammoth, the grass, is still between his teeth. Not fossilized, not a mineral impression of grass. Actual, partially chewed, identifiable grass, frozen mid-grind between molars that were in the middle of a meal when something killed this animal so fast that the jaw never completed the chew. He is 44,000 years old, and he is the single most important piece of evidence in one of the most contested arguments in the history of prehistoric science. What actually killed the mammoths, and how fast did their world end? In 1900, a Siberian hunter named Semyon Tarabikin reported a powerful odor of decomposition rising from a riverbank near the Berezovka River. A full expedition was mounted by the Russian Academy of Sciences in 1901, led by zoologist Otto Hertz and geologist Eugen Feisenmeyer, who made the journey under extreme conditions of cold and terrain to document what turned out to be one of the most significant paleontological finds in history. They found the mammoth seated upright, its hindquarters partially decayed from brief thaw exposure, but its stomach contents perfectly intact. 30 pounds of undigested and partially digested food, grasses, sedges, mosses, and flowering plants that were identifiable to species level. Among them, buttercups, in bloom. Feisenmeyer documented their presence in his 1926 account of the expedition, a detail that fixes the season of death with botanical precision: late summer. And between the molar teeth, described by Hertz as still green in color, was partially chewed grass. The animal had not finished swallowing. The numbers that followed from subsequent analysis are staggering. Russian paleontologist Nikolai Vereshchagin, examining similar Siberian mammoth finds in the 1970s, calculated that to freeze a mammoth's stomach, contents intact, to preserve undigested plant material before gastric fermentation could break it down, would require ambient temperatures to drop to approximately -40 degrees Celsius within hours of the animal's death. Not a gradual seasonal cooling, not a slow descent into permafrost conditions. A sudden, violent atmospheric cold event of extraordinary magnitude. Botanical analysis of the stomach contents identified more than 40 plant species, including several that no longer grow in Siberia at all, indicating that the Pleistocene Siberian ecosystem was dramatically warmer and more vegetationally diverse than the modern tundra, and that the transformation from one to the other was, in geological terms, swift. The death posture reconstructed for the museum specimen in St. Petersburg, where the Berezovka mammoth remains on display today, shows the animal seated, with fractures in the right foreleg and pelvis consistent with a fall into a pit or sinkhole. The conventional explanation is coherent. The mammoth stumbled into unstable ground during summer grazing, fell, could not extricate itself, and died. Contact with the permafrost-floored sinkhole cooled the carcass rapidly enough to preserve the stomach contents. It is a mechanically plausible sequence of events, but a sinkhole does not explain the specific preservation of the buttercup still recognizable between the teeth. And the Berezovka mammoth is not alone in this kind of preservation. Multiple Siberian mammoth specimens show interrupted feeding, summer stomach contents, and soft tissue preservation suggesting death was not gradual. If each one fell into its own convenient sinkhole at exactly the right moment of exactly the right summer, the coincidence begins to accumulate weight. Some paleoclimatologists have proposed localized katabatic wind events capable of producing sudden extreme cold over small geographic areas. Others have modeled volcanic winter scenarios. Immanuel Velikovsky proposed a global catastrophe. The mainstream rejected that framework thoroughly. But the specific problem that drove the speculation, how do you freeze a mammoth's last meal before it digests, has not been satisfactorily resolved within conventional climate models. It remains in the quiet corners of the scientific literature an open question. What the Berezovka mammoth offers more than any other Siberian find is a frozen moment, not a skeleton suggesting a life once lived, not an abstraction. A specific afternoon, a specific plant in a specific tooth, a specific instant when something stopped. Whatever that something was, it was fast enough to outrun digestion. And it happened, apparently, more than once. The Berezovka mammoth is the most dramatic single piece of evidence for a sudden freeze event. But the most complete mammoth ever found tells a different story. Not a violent death, but a quiet one. A newborn calf, a river, and a window into a world 42,000 years gone that science is still barely beginning to open. Lyuba, the baby mammoth. In May of 2007, a reindeer herder named Yuri Kuti was following his herd along the banks of the Uribay River on the Yamal Peninsula in northwestern Siberia when he spotted something small and brown in the mud. He thought it was a doll. He called his sons over. His sons called the local museum. And what they had found, lying in a riverbank like a lost toy, was the most complete, most perfectly preserved large Ice Age animal ever recovered by science. She was 42,000 years old. She still had her eyelashes. Lyuba, named after Yuri Kuti's wife, was transferred to the Shemenovsky Museum in Salikard and made available for international study. Principal analysis was conducted by Daniel Fisher of the University of Michigan Museum of Paleontology, whose initial findings were published in 2009 and have been supplemented by ongoing research ever since. CT scanning was performed at multiple facilities, including a medical center in the Netherlands and a specialized industrial facility in the United States capable of imaging the full specimen at high resolution. The results of that scanning produced the first complete three-dimensional internal map ever made of an Ice Age megafauna specimen, revealing intact organ cavities, a thymus gland, and tracheal cartilage rings so well preserved that researchers could measure their dimensions directly. The facts of Lyuba's condition require a moment to absorb. Her trunk retains its shape and internal cartilage. Her eyes are closed, with lids intact and eyelashes countable. Her footpads show skin texture. Her digestive tract contains her mother's milk, not a trace of milk, not a chemical signature suggesting milk was once present, chemically analyzable, compositionally distinct milk still inside the stomach of an animal dead for 42 millennia. Daniel Fisher described her as complete in a way that no other mammoth specimen approaches. Fisher's 2009 analysis estimated her age at death at 30 to 35 days. She was a newborn, still entirely dependent on her mother. Clay particles found in her respiratory tract were consistent with drowning or suffocation in mud, suggesting she fell into a waterlogged hollow and could not escape. Her death was not violent and not sudden in the dramatic sense of the Berezovka mammoth. It was quiet and quick, and 42,000 years later, it is still visible in every detail. Alexei Tikhonov of the Russian Academy of Sciences identified lactic acid bacteria in Lyuba's nasal passages, pharynx, and digestive tract. These bacteria had produced enough acid to essentially pickle the carcass from the inside, providing a preservation mechanism that worked in parallel with external freezing. This internal chemistry is understood to have inhibited decay bacteria from establishing before the external cold could complete the encasement. It is a two-stage preservation process, internal pickling followed by permafrost sealing, and Lyuba's body is the clearest evidence ever found that both stages can work together with extraordinary results. Ethan Shirley of the University of Michigan, working with Fisher, found that Lyuba's skin retained enough structural protein that individual layers of epidermis and dermis could be distinguished histologically, CT scanning revealed intact footpad cushions, the soft tissue structures that in living elephants absorb the mechanical impact of each step, providing the first direct physical evidence of how mammoth feet functioned. She has been exhibited at the Field Museum in Chicago, the Natural History Museum in London, and the American Museum of Natural History. Scientists keep finding new things to ask her. The mainstream explanation for Lyuba's preservation is the best supported account we have for any Siberian soft tissue find. Mud drowning, lactic acid pickling, permafrost encasement, a specific chain of events, each supported by physical evidence found on the specimen itself. It is a credible, internally consistent explanation, and it should be taken seriously. But the lactic acid mechanism is only known to have worked because it worked. We have never observed it working. We cannot replicate it in controlled conditions for a large-bodied mammal. And the chain of coincidences it requires, the right sediment, the right temperature, the right bacterial load, the right season, represents a preservation event of such narrow specificity that it should be extraordinarily rare. Yet the Yamal Peninsula and the surrounding Siberian permafrost keep producing finds like Lyuba with a frequency that strains the definition of rare. As the permafrost thaws globally, the rate of discovery is accelerating. Researchers have begun to say quietly that we are not finding these animals by chance. We are beginning to read a filing system that the Ice Age built, and climate change is opening the cabinet. Lyuba drowned 30 days into her life in a mud hollow on a Siberian river in a summer 42,000 years ago. Her mother was almost certainly nearby. Mammoth calves at that age do not wander. Whatever happened next, the permafrost sealed the record before anything else could. And now, she travels the world's great museums while scientists continue to find in her eyelashes and her milk and the pressure ridges of her footpads details of a vanished world so specific, so intimate, so present that the distance of 42,000 years seems for a moment like almost nothing. These 10 bodies, pulled from bogs and glaciers and salt mines and permafrost and desert sand, span a range from 30 days old to 42,000 years dead. They come from Denmark and China and Egypt and Iran and the Alps and the Siberian Arctic. They are a mammoth calf, a woolly rhinoceros, a Copper Age man, an Iron Age sacrifice, a mummified royal, a tattooed noblewoman, a set of miners, and a population of desert-dried people who had no business being where they were found. On the surface, they have almost nothing in common, and yet they are linked by a single thread that runs through every item on this list. They should not still exist. The universe is very good at taking things apart. Biology dismantles organisms from the inside. Bacteria consume everything. Time grinds stone to sand and bone to dust. The default state of the past is absence. And yet here are 10 cases where the default was overruled, where a specific combination of cold or acid or salt or arid heat created a window through which a specific moment in time simply refused to close. Science has an explanation for each of them, and those explanations are often good ones. The permafrost chemistry that preserved Lyuba is real. The bog acidity that tanned the Talon man's face is documented. The desert desiccation that mummified the Terran women is straightforward physics. None of those mechanisms should be dismissed, and none of them are in genuine dispute. But taken together, these 10 cases point towards something the individual explanations do not address. The staggering volume of information we have permanently lost, measured against the tiny fraction that survives, and the question of what those survivors are actually telling us about the worlds they came from. The Berezovka mammoth died mid-chew. Utzi was assassinated and never saw it coming. The Talon man's eyes were closed by someone who cared enough to do it, after a killing that required no such care. Lyuba drowned 30 days into her life. Each one of these is not a specimen. It is a moment, specific and irreducible and human, or animal, or both, preserved by an accident of chemistry that had no reason to cooperate and cooperated anyway. Most people hear woolly mammoth and think museum display. Dusty reconstruction, educational placard. You watch this far, which means you understand that these are not relics of a dead world behind glass. They are the dead world, intact, speaking directly across whatever distance of time separates them from us. The milk in Lyuba's stomach, the grass between the Berezovka mammoth's teeth, the eyelashes, the fingerprints, the screaming face. These details are not scientific footnotes. They are the actual content of those lives, suspended in ice and salt and acid and sand, waiting for someone to ask the right question. This channel exists for people who cannot walk past a museum display case without wondering what else is in the ground, what else is coming up, what the permafrost has not yet released. This is your archive. Hit subscribe and make it official. Then go to the comments and tell us, which of these 10 preservation cases carries the question you think science has not yet found the courage to fully ask? Make your case. The floor is yours. The permafrost is thawing. Every year, more come up. Mammoths, rhinos, people, intact and patient and full of information the world had no right to keep. They were never truly buried. They were waiting. Somewhere in Siberia right now, a riverbank is eroding. A tusk is breaking the surface. A face is appearing in the mud, perfectly intact, 40,000 years of silence, ready to speak. The cold kept them. Now it is letting them go. Subscribe, so you are there when the next one surfaces.